Okay. Given the short session, I think my clock shows that it's time to start, and so I think we're not going to wait. We're just going to dive right in. So this is privacy preserving measurement at IETF 115. I hope you're in the right room. This is your IETF note well. As always, the IETF's IPR and good behavior policies apply. Please familiarize yourself with the note well if you are not already familiar with it. As this slide notes, if you are in fact in London and not in New York City, you are going to need to wear a mask if you're in the room. Thank you for helping us to keep all the on-site participants safe. I think these links are probably not as helpful now. Most importantly, the agenda bash. This is our proposed agenda for the 1-hour meeting that we have. If anybody would like to suggest a change to the agenda, now would be a good time. So I'll just repeat that one more time. This is our agenda bash. Here's our proposed agenda. If you have questions about the agenda or if you'd like a change to it, please come up to the mic or add yourself to the queue. Not seeing any requests for changes to the agenda, so let's get started with the DAP editors. I'm going to give you a 30-minute timer, and you can divide that time as you like among these topics. Please do leave plenty of time for discussion. If you take all the times with your slides, you're not going to get any feedback.
Noted. I have requested to screen. Oh wait, I'm trying to request. I wanted to request to share slides. Sorry.
Okay, let's get the technical issue sorted out first.
I have requested to share slides.
Okay, let's see.
You could also run them if you prefer. First one, staff update. Hey, Shan, we can hear your keyboard. You don't want to mute yourself.
Okay.
Let me see if I can fix this.
Thank you.
Cool. I see the slides. Am I running it? No, that's okay. You ready to go?
Yep.
All right, so this is just going to be a very quick update on recent changes to the DAP spec. I'm going to talk a little bit about the issues that we want to address in the immediate future and talk a little bit about what's like our long-term objectives are. And then I'll just quickly update folks on implementation status. So the major change in the current draft DAPO2 is this new notion of query types. So folks might remember from the previous version of the spec, the way we would pick a set of reports to aggregate is the collector would specify a time interval, and then the aggregators would go find a set of reports that have timestamps that fall in that interval and aggregate those. This is useful for a lot of use cases, but it doesn't solve every problem that we have. So we decided we need to generalize this. So there's this new parameter of the task configuration called the query type. Basically, what we do now is the aggregators are going to partition reports into what we call buckets, and then the collector's query actually specifies a sequence of buckets, and this is what we now call the batch. So you can think of a bucket as, for example, for the old semantics, a sequence of non-overlapping time intervals. So now we have two query types, one that specifies preserves this semantics from the previous version. We call it time interval. And then we have this new one called fixed size, where we don't actually care how the aggregators partition reports. All we care about is that they're all roughly the same size. So that's what we accomplish with that. So we're anticipating wanting a lot of flexibility here. So as folks start to use the DAP spec, I encourage you to think about, whether or not your use case fits, and we'll figure out what we can do to accommodate it, hopefully by spelling out a new query type. Next slide. One minor change I wanted to highlight is we now have this notion of task expiration. Basically, the consideration here is primarily operational. It's useful for capacity planning, figuring out how long you have to keep around the various assets that we end up computing in the DAP protocol. It's useful to know what is the maximum lifetime that a task will be around. So that's what this new parameter accomplishes. Next slide. The final major change is to HTTP client authentication. So we know that we're going to need client authentication for a couple of channels. One between the aggregators, the leader makes requests to the helper, and we want to authenticate that request. And similarly, the collector is going to collect request aggregates from the leader, and we want to authenticate that channel as well. So in DAPO1, we had spelled out a kind of a simple, dinky bearer token-based approach. And we decided in DAPO2 to, instead of specifying a concrete scheme, we would just spell out requirements for establishing the secure channel. And the idea here is that we wanted to permit lots of flexibility here for implementations, because this is HTTP client auth can be tricky. Next slide. So the plan for the next spec, DAPO3, is basically to address some minor bugs that we noticed while we were working on the implementations of DAPO2. So these are things like at issue 362, we ended up making anti-replay requirements a bit stricter than in the previous draft, and we're wondering if that's actually a regression. So there's some discussion happening there. It'd be great to get people's feedback. And then another issue to highlight is extension processing semantics. We haven't actually fully spelled this out, and as we'll see later, we're going to propose a new extension, so I think it's time to figure this out. And then beyond that, Tim is going to talk about some API rework proposal. This is like the only major change that we foresee doing. And then beyond that, integrating Poplar 1 is something we want to get to in the medium term future. Editorial changes, I think this presentation in the spec is wanting a lot, as many have pointed out. And then beyond that, we wanted to start doing all the things that makes a good spec good: experimentation, security analysis, and so on. Next slide. So very quickly, there are two implementations of DAPO2 that we're aware of, one by Cloudflare and another by the ISRG. We've been working together closely on our implementations. We're quite confident that we're at a point where we could really start experimenting. So if there's interest, please ping the list. Also, the PPM channel in the IETF Slack is quite active, so we'd love to see you there. And finally, I wanted to flag this draft that David Cook is working on. He's from the ISRG. It's basically spelling out some ways to do interop testing between implementations, and that's been really useful for us. Thanks. I didn't leave much time for questions, but if there are some quick questions, let's hear them. If not, we can move on to Tim, who I believe is next in the agenda.
Okay, it'd be great if somebody could take over note-taking while I'm speaking. Okay, Sam, it looks like you're going to be driving the slides. Let me pull up the notes. And all right, let's dive in. So for the last few weeks, I've been working on a new version of the HTTP API for the distributed aggregation protocol. Oh, thanks. So currently this exists only as a memo that I've written up in a pull request on GitHub that sketches out the proposal. So there's a lot of work to do before we'll even have a PR that could actually be merged into the protocol text. But what I want to do at this stage is socialize this idea to the working group and gather feedback to make sure that we've identified the right problems and that we're headed in the right direction to solve them. So I think it's important to do this kind of thing sooner rather than later. The idea being to minimize disruption to DApp implementations who'd have to adopt a new API. Since, as Chris just highlighted, there's only 2 of them known in public. Hopefully, it's cheaper to have them, to have us update our implementations than to do this like months or maybe years down the line. All right. So on this slide, we see the current API surface specified in DAP02. So these 7 HTTP requests drive the upload, aggregate, and collect subprotocols. So what we notice, next slide, please. One thing we noticed right away, thank you, is that the thing described by the relative path is variably a noun or a verb, which I think makes it then awkward to to resolve the verbs against the verb that's in the HTTP method. So we see this because, in fact, reflected in that more than half of the API paths here use post, which to me suggests like that the HTTP speak for I want to do something to the thing at this path, but the semantics aren't super clear. Next slide, please. Crucially, post also means that the requests are not idempotent, which makes it unclear for protocol participants how they're supposed to go about recovering from faults. This is especially a challenge in the aggregate subprotocol, since that's all about the stateful multi-round execution of the VDAF verification algorithm. And finally, a problem with the current API layout is that there are some cases where servers have to partially parse a message to extract a value like, say, the task ID, which is needed to then parse the rest of the message, because there are cases where you have to look up the task to figure out what VDAF or query type is in use, and that informs the structure of the remainder of the message in the request body. So that's awkward at best and risky, I think, in some cases. Okay, next slide, please. So with those problems in mind, let's look at what I'm now proposing to do instead. So in designing this, I started by enumerating what are the resources that this API is managing? What are the things? The idea being to let the HTTP methods be the verbs. So that's enumerated in this table. So the resources ought to be familiar from DAP02. It's HPKE configurations, reports, aggregation jobs, aggregation shares, and collections. So we notice that the new paths contain much more information. So in particular, the task ID and in some cases the unique identifier for the resource are there in the relative path. And we see that most resources are now subordinate to a task, with the exception of the HPKE config, because those can be global, so it would be a bit awkward to make it look like everything else. So implementations have to implement the methods listed in the required methods column, but an implementation could, implement more methods on some resource if they choose to, or if it makes sense for them. Next slide, please. So I also tried to pay attention to making better use of put so that we can get idempotence. So for example, if an aggregation job, you do a put request to create one, since there's a unique identifier in it, which allows the server, the helper in this case, to sort of disambiguate repeated requests. But advancing the state of an aggregation job, which is, again, that's the stateful VDAF verification algorithm, that does incur a side effect in the helper of advancing it to the next round of verification. So that's a post since it has a side effect. Next slide, please. All right. For some resources, the unique identifier for a resource appears in the URI because this is for cases where the unique identifier is assigned by the requester. So in a report, the client assigns the report ID. For aggregation jobs, the ID is assigned by the leader. Next slide, please. In other cases, it's the message handler that will assign the unique ID of the resource. So the put is to a resource for aggregate shares, plural, or collections, plural. Then it's the handler of the message's responsibility to sort of assign a unique identifier and construct a URI. So for that reason, in these cases, we don't specify what the URI for the individual resource is, just what methods it supports and what the what the semantics of those calls are. Next slide, please. So despite being significantly different and I hope better, the migration from the DAPO2 API to this proposal hopefully ought to be relatively smooth for implementations. So this table enumerates the old API endpoints with the corresponding new ones. And there's actually a one-to-one analog in almost every case. So the migration hopefully would just consist of adopting new message types, since in some cases the messages no longer need to contain information like a task ID or some other unique identifier, as that's been hoisted up into the URI, and update the paths at which a message is handled. But the actual message handling code shouldn't change much. The exception is handling of aggregate shares, which in DAPO2 was one synchronous post request to initiate from the leader to the helper to initiate the construction of an aggregate share and then obtain it. In this proposal, I've changed the handling of aggregate shares to align it with the leader's collect resource. Primarily, this is for symmetry, since the two resources, the helper aggregate share and the leader collection, they're very much the same. This also enables the helper to asynchronously compute aggregate shares, since that process can be expensive and take some time. Okay, next slide, please. So there's a lot more to all this that we didn't have time to discuss today, and a lot more work to do. So all of this needs some more analysis to show that we can do error recovery in all the cases that we care about. And there's some open design questions. So for one thing, does it make sense to align the aggregate share resource on the helper with the collection resource on the leader? Further, in my opinion, the collection resource right now, it's rather awkward. I'm not sure it's the right noun that we have. So Chris Patton suggested that we could call this a collection job instead, which I think is better. But maybe we should think about this as a query, right? In the sense that the collector is making a query against an aggregate that's been compiled by the aggregators. The other thing is there's some awkwardness in the collect API that we didn't discuss just now because we don't have time. That's there because we're trying to write one API for the collection flow that accommodates both the time interval and fixed size query types that Chris discussed just earlier. So I think we should bash out, like, is this a good goal? Or should we accept that these two things are fundamentally different and surface two different APIs, each better fit to the specific task? So I'll close with a call to action here, which is that if you've been following all this DAP and PPM work and you find it interesting, but you don't have a good handle on the zero knowledge proofs and so on, but you do know your puts from your posts, please come and help us out with this. So there's a pull request linked here, and otherwise we'd love to hear from you there on GitHub, in the PPM mailing list, on Slack, wherever. All right, that's it. Thanks very much.
Martin Thompson.
That's a hell of a walk. Martin Thompson, thanks for walking through this, Tim. Can you walk back a slide or two? All right, so I'm seeing a bunch of effectively URI templates, which is all reasonable. My question is, does the client determine any of the things that are in those curly braces and in those URLs?
Yes. So the client chooses the report ID when it uploads a report. Additionally, well, I'll let Chris and Shan speak to the task provisioning extension later, but I think they'll explain how the task ID can, in that setting, have something to do with the client.
That tends to produce interesting problems. It may be that you're far enough down the path that it doesn't matter as much in this context. But if you have the ability for clients to for instance, for the same task ID, have multiple clients. They might, for instance, produce the same report ID or whatever other pieces you have there, which creates potential collisions and other things. The usual practice here is to have the client request the creation of a resource and the server to tell it where it is. And that means you're losing some of your idempotency, but in exchange, you get a lot more resilience on the server side against things like clients that might accidentally or maliciously try to get collisions out of the resource identifiers. It also gives the server a little bit more control over how it structures identifiers for its own purposes. So if the server is in a position where it needs to know how to route some of the queries to each one of these resources, if it gets to choose the identifiers, then it can do things to optimize and change the way it processes these requests. So I would recommend maybe in the cases where you're trying to create a resource, you look at using post with, say, a 201 response that contains the location of the resource that's created as a result. You can get back a lot of your idempotency by making that create thing do nothing of consequence, and then have puts to update the content of those resources once you're done, if you particularly care about those sorts of things.
I am a bit weird. One of the nice properties of Prio, hopefully the mic is better now, by the way. One of the nice properties of systems like Prio is that the client only speaks once. And I think that's something we should strive to maintain. But I do take your point about the risks of clients choosing report IDs is well taken.
Yeah, so the other thing is it's totally okay to use post and treat it like it has idempotent semantics, because you know what the semantics of the operation is. And so in the case where you're posting and you didn't get a response from the server, and you're reasonably confident it's got some other information that can be used to prevent a replay or something along those lines, then it's totally okay to just do another post. It's fine. You won't necessarily engage all the automated logic that might be in some stacks to do the post again. But then again, if you're doing it in a browser, you might get retries on posts anyway, just saying.
Okay, let's keep going. Chris, do you want to try sharing slides again?
Oops. Oh yeah, here we go. So we're on to differential privacy, right? All right. Everyone can see that? Cool. All right. Well, oh, actually, let me set my timer real quick. Okay. So this is actually not going to be DApp specific. This is more about the land of PPM in general. We've been talking about the composition of differential privacy with protocols like DApp in various different venues. And, you know, we're reasonably confident there's a lot we can do here. But to date, this working group at least hasn't come up with anything concrete, either in the DApp spec, the VDAP spec, or anywhere else in the PPM working group. What I want to try to pitch today is that we need to start working on a draft that provides some concrete guidelines for integrating specific differential privacy mechanisms with specific PPM protocols. So just to get a little at the motivation here, let's ask, I think the starting point should be like, what does DApp provide, a protocol like DApp provide, and what does it not provide? So DApp specifically provides MPC style security guarantees, where basically you want that the collector can compute some aggregate over some measurements without seeing the individual measurements themselves. So in our threat model for DApp, this is certainly like a necessary property for privacy, right? But there's really no reason to think that this is going to be sufficient for every application. And kind of the canonical example of this, Chris Wood brought up at the last IETF. I have a link here to the slides. You should go check it out. There's this risk of overexposing a user if, say, some automated system has that measures the client multiple times in a single batch or across multiple batches over time. Either way, there's this risk of overexposing information about an individual user. So what can we do about this? Well, I think mechanically at the level of DApp, there's really not much we can do that's going to be good for all situations. So the way, an alternative way to approach this is to kind of formalize what do we mean by privacy. And one answer to that question is this notion of differential privacy, which has been around for a long time. And I'll give a quick overview of my own understanding of how DP works. You basically imagine you have some randomized query algorithm that is exposing aggregates over measurements. And the property that we want is the distribution of the output of the aggregate should not depend significantly on any one individual's measurement. And we can formalize this by thinking of the difference in the distribution of the output between two databases that differ in exactly one measurement. So as kind of like an intuitive example of how this would work, if we have some secure method for computing the aggregate to make it differentially private, what we do basically is sample randomly some noise from some appropriate distribution. And instead of handing to the collector the aggregate, we hand to the collector the sum of the aggregate with the random noise. And intuitively, if we perturb the output enough, then the idea is that we hide the contribution of any one individual measurement. So that's a really nice intuitive idea, but differential privacy has a lot of subtleties to it. The main kind of consideration when you're applying DP is the privacy budget. So basically the degree of privacy that you get from the system is going to depend on how many queries you allow in the system, as well as what is the exact nature of those queries. And but despite this complexity, I think there's a clear win here to be able to compose PPM protocols, NPC style security goals like DApp, or even this what security properties we get from something like STAR. Differential privacy is going to be interesting for a lot of different applications. So the question is how. And in all of the discussions, I think the main thing to take away is that there's not one there's not one solution that's going to fit every protocol. The kind of the ideal mechanism, or even like the set of suitable mechanisms, is going to depend first off on your base protocol. So differential privacy is going to look very different, but for STAR versus DApp. And also, you have to be very careful about considering the application and the nature of the data that you're collecting. So I think there's a lot of open questions here about what would be the precise scope of such a draft. So on the one hand, it could just be like guidelines, like these are different DP mechanisms that might apply to a given protocol. One thing that would be really useful, something that the IETF is quite good at, is spelling out algorithms for sampling noise from a given distribution. Basically, take devu random and map it to a random point in a Laplace distribution or whatever. And then there's like guidelines for enforcing privacy budgets. I mean, as a cryptographer, my analogy is like something like safety margins for an AEAD scheme, an encryption scheme. Is there an analogous kind of set of guidelines we can develop for differential privacy? And then another idea is, like something we can do is spell out concrete mechanisms. There are lots of prior work on this that apply more or less directly to protocols that we have already. So yeah, I think there's a lot of interesting stuff we can do here. I'm kind of just throwing out ideas. I would love if someone in the room who has some expertise in differential privacy had a strong opinion about what we should do here. And with that, we have 5 minutes for questions.
Eric Squirrela, as I say, more a comment than a question. We should do nothing here. We have like already a very complicated specification that we're trying to get out the door. They're independent pieces of work, and we should not do this one until the first one is done. It's consuming the exact same resources. So, like, I think I don't mean to give you the impression I don't think it's important. I think we should sequence it next, but I think that like trying to do them both, like the only thing we should be doing right now is making appropriate changes to DAP to make this possible if necessary. And if there are none, we should do nothing. I say, again, I don't mean to make light of this problem. I think it's a very real problem, but I think it's also a problem that is not like very straightforward. And so I'd like to like keep like got my eye on the ball.
Thanks, Ecker.
Jonathan Hoydens, Cloudflare. This is more, I guess, related to the first presentation in a way. When you have different query types, does that break or make differential privacy harder or worse because there's different groupings of queries that are now possible, and you now have to consider the interaction between them on how it leaks information?
Yeah, so one thing that we're trying to guarantee in the spec is that regardless of the query type, you have a proper partitioning of the reports. So no report is going to be used in more than one batch. That's something we try to guarantee. However, like to your point though, there are considerations for differential privacy. The main one would be the size of the batch. So my understanding, and this is like I hope I see Charlie Harrison in the room, and I'm calling him out to correct me here. My understanding is that we have to use like basically the batch size that we're aiming for to tune our differential privacy parameters. So for fixed size, for example, we enforce a maximum batch size, and that's like one of the considerations there.
Yeah, I can just quickly speak to that. Like the batch size, I think the batch size is important for some of the deployments that we're considering for differential privacy, like namely the deployments that are similar to the COVID privacy preserving analytics, like the NPO work, where noise is added on the client. In that case, the total amount of privacy is based on how many clients you're kind of adding together, because you're summing a lot of noise from a lot of clients. In the central case where the like aggregators themselves are adding noise, the batch size is not related to the privacy of the output. It's only related to the kind of like relative area that you're going to get.
So if maybe this is just completely mistaken. If a record is queried, let's say I do a query that says, I want to know the average of all things, every single record, I want to know what the average is. Does that mean I now can no longer do any queries because they can't appear in two queries?
Yes. Right now.
I think that question is for you, Chris.
Chris, you're on mute. You're still on mute.
Can you repeat the question?
If I make a query that says, give me the average of all things, I want to know every single record, what's the average? Does that mean I can no longer do any more queries because they've all appeared in one report? One query?
At some point you have to stop. Like you don't get to do like a rolling average. Like give me the average of everything so far. At least in DAP, what we're requiring you to do is at some point you have to say, this is the end of my batch. So yeah, the intent is that batches never overlap.
Right. I mean, this goes back to the discussion we had, sorry, Eric Squirrela, discussion we had last time about drill down, right? And so once again, we're going to need to address that problem at some point, though I understand we decided not to address it like at this exact moment. And that's another reason why the DP problem will be so difficult.
I agree. I think that's it for the DAP editor's time. Thanks, everybody.
Great. So I see Eric back in the queue. But Chris and Sean, this is your your time for in-band task provisioning. Sean, I saw you in the queue earlier.
Yeah, I'll just ask to share slides. Sorry, can anyone remind me how to share slides? I'm just seeing
Yeah.
Chris is passing me control for sharing slides, but I don't know where else do I click.
Let's try one more time. I'm going to revoke your slides. Try once more. There you go.
Cool. There you go. Let me turn on my camera as well. Hi, everyone. Next, I'll talk about the in-band task provision. Right now, it's individual draft for an extension to the core DApp protocol. First of all, let's talk about the motivations. So today, the DApp protocol doesn't actually define how a task should be provisioned or configured. It basically mentions it will be done out-of-band with leader and helpers agree a particular mechanism to share the parameters for configuration and then provision tasks securely. But here we want to introduce a new mechanism for provisioning task purely through the existing flows, especially the upload flow and the aggregate share flow, and use the extension mechanism without introducing any extra flows. And hopefully this will be useful for many deployments, and many leader and helper deployments can just provision tasks in the same way without defining any extra mechanisms. Now the basic protocol architecture, here we introduce a concept called a task author. Author is basically a logical participant that it defines the task. It defines what configurations goes into a task. And we assume it has ability to send the task configuration objects, which I'll show later what it contains, to the clients. Now, in reality, author could be implemented by the leader or the collector. So we don't have any more trust to the task author than we have on the aggregators. So the basic flow is the following. The author will send the task config to the clients. The clients will verify the task config, make sure they make sense. And then when it decides to opt into a task, it will send the report as usual, but contains task config as part of the extension data. And this report will be received by the leader, which is going to do its own procedures for checking the task configs and verifying task makes sense, and then share the exact same task config with a helper using the report share struct as defined today in DApp core protocol. So the key point here is there is no task provisioned in advance until the very first report is received from the leader. And also there's no need to define any auto-band mechanism between the leaders and helpers for task configuration purpose. Now, if the aggregator does not support task-proof extension, in today's draft, we will simply ignore the task config and proceed as usual, assuming the task has been configured in other mechanisms. So the task config object itself is basically the task-specific parameters described in the core protocol. Here we basically group them into different structs based on their purpose. There is a query config, which includes things like minimum batch size, maximum batch size, for example, for the fixed size query. And the VDEF config contains all the VDEF specific configurations, like the type of the VDEF and the buckets it need for example, pre-03 histogram. And here because the task is created on the fly, so it's necessary to have a mechanism for all parties to derive the same task ID based on the same task configuration. So a task ID here is simply created by a SHA-256 hash on the serialized task config object. Just going into some details on the client side, client simply receives the task config, sets the extension type to task proof, and then encode the task config in part of extension data, which itself is part of report metadata. And on the aggregator side, in leader and helper, they both will check the task config they received and run the same task ID generation mechanism and make sure the task ID passed in matches the generated task ID. And here, opt-in basically means the provision task is either unrecognized, which means the leader or the helper needs to provision this task, or the config received matches an already configured task. We haven't mentioned about the collector side, but hopefully the collector side will be very simple. It's very much oblivious to the use of task proof. It should have ability to receive task config from task author. After that, it simply sends the collector request, including the task ID, generated from the same task ID hashing mechanism. And here are some links for the draft and the GitHub repo. There is one reference implementation in Daphne, which is still in progress. So the main purpose of this presentation is to show everybody that task proof is useful for many deployments. It may not be useful for all deployments, but we want to gather more feedbacks and see whether the group wants to adapt it as a working group extension. That's it. So I'll use the remaining 4 minutes for questions, please.
Eric Scorla. I guess I'm not really persuaded by the problem statement. I certainly understand why you might want to have dynamic configuration, but I don't understand why telling to the client is a good idea. It seems to me that basically that there's a relationship between the collector and the leader and helper, and there should be the collector and the client, and that's the appropriate place for this information to be carried. And I don't understand why you're telling it to the client. That just seems like not the design, not a natural design.
Okay, so if I understand correctly, you're asking why we are sending a task config to the client?
No, I understand why the client needs the task config. Why are you tunneling it to the client? That is, why don't you provide the task config directly from the collector to the leader and helper?
That's basically what the core protocol is suggesting. But I think the problem is there isn't a specified mechanism for doing that. So if you have a leader helper, if your organization manages many leader helper pairs, then you need to make sure either you have a unified mechanism for all these other organizations that working with you as an aggregator, or you have to maintain basically different ways for distributing task configs to all these other parties.
You're misunderstanding me. I'm not opposing having a protocol for provisioning the task config. What I'm saying is that protocol should be two separate protocols. One for really the only protocol that's actually needed is the one from the collector to the leader and helper, and that should be standardized. And the client should not be part of the picture.
You certainly could standardize from collector to leader helper, but I think there are extra benefits when it comes from the client side. So in this case, the client knows exactly how the task will be created. So the task the client's report will be aggregated in will have exactly the same task config as the client has seen it. If you standardize just between collector and leader helper, then you're basically asking the client to trust whatever the leader helper, the leader or task author sending it is exactly the same as the server side used to provision the task.
Yeah, are you talking about malice or incompetence?
Are
you talking about malice or incompetence? Malice or incompetence by the
Malice or incompetence?
Oh, malice, yeah. No, I'm talking about the confidence.
Okay, but like, if you want, if this is your problem, then we should just have checksums on all the configs, which we in fact discussed previously. But like, here's the thing: the client cannot implement this. The task config is not even remotely sufficient for the client to implement this, because the client needs the instrumentation in the client code to collect the data that goes to the task config. So like, the client needs all kinds of garbage, and not just the task config. And so like that needs to be delivered by some other channel. And the client has all that stuff. So like, yeah, like again, I'm on board with like dynamic configuration, but this is like not the right approach. I'm sorry, Chris, did you want to respond to me or
What's the other garbage?
what? The like probes in the code that like collect the data.
Oh yeah, sure, yeah.
The software, the actual software. I mean, the thing I understand is like that this is the reason we didn't do this in the first place was because in order to make this work, you've got to like modify the client code. And so like, I mean, even remotely provisioning the client is almost impossible because you got to modify the client code. And like the number of clients that can be remotely provisioned with like new code with like a code update is very small, right? And so like that's the machine that's complicated.
Nick?
I will be brief. I think my question was, I can see some benefits from doing in-band provisioning, and the draft seems to suggest that the client will decide based on some of that configuration whether this seems like an acceptable task or not. But if we are going to do that, I feel like there would need to be more richness in that configuration for the client to make a good decision about what's acceptable or not. That seems like a sort of privacy type decision, and that's going to need a lot more richness than just batch size.
Yeah, so there are some checks we think the client could do. For example, we introduced the task expiration from for draft 2 in depth. The client could check whether the task has expired and it's not worth participating anymore. There could be more advanced checks, like if we introduce DP, whether we do that is another question. But if we do introduce DP, we might want to check on the client side of whether the client is willing to participate in a task with a certain DP guaranteeing. Yeah.
Hi. Well, I want to say I'm speaking as somebody who implemented a client that reports metrics. I appreciate Ecker's point that it takes code to implement new metrics, but it does seem to me like there's room here for essentially dynamic reconfiguration of how, especially numeric values, are reported. So if I decide that I've been measuring the average of some value, but actually I want to switch and start measuring the histogram of that value, do I have to push out new code to all of my clients? Do I have to reach all of my clients through some sort of external control system, or can that actually be done in-band through DAP? So that kind of narrow use case, I think there could be value here.
Yeah, I think there are two different things here. There's one is the client-side implementation, and the other is the task distribution. I think in today's step, task distribution is not defined. It's very much deployment specific or outside of depth scope. But for the client side, I think there are many scopes for the client to do things to make sure the privacy guarantees and the transparency it provides. For example, we would like clients to log all the task configs it has received, so the client itself knows what kind of task it has participated in. So in a nutshell, yes, the client will have to do extra work to implement this, but if you are considering you're already receiving the task config from the server and you might also want to log them, then just putting it into the metadata and send it to the server side, I don't think it's a massive leap from what's already being done.
Sorry, it's me again. Chris, unless, are you just in the queue, Chris, or are you going to say something? Right.
One second.
So, I mean, go ahead. No? I mean, Ben, I mean, you're certainly right that like it might be nice to reconfigure the client like without having to load new code, but like that's not going to be done. First of all, like this doesn't provide the channel for doing that, so you still need a channel, and that channel is like not going to be done with like with high probability of setting new task configs. It's going to be done with like some whatever remote configuration mechanism your product already has, and like that's again a much more rich mechanism than this thing. And so like I just don't think it's very plausible. Like the task config will be enough to like reconfigure the client. But again, I just think that's like missing the main point, which is that like that you have like not adduced a good reason to tunnel this data through the client to the different helper, and it was much more sensible is to like configure that directly downward from in both locations, and then if you want to compare them, compare hashes. But like it just I just don't understand why I just think the tunneling thing is too cute by half.
So I'll just quickly say, so I want to point out, first of all, that there is much more to the thing that is actually serialized in the extension than just like, say, the min batch size. Everything that controls the aggregator's behavior, at least like in the context of like the interoperable protocol, is specified in there. So it's important, you know, for many reasons for everyone to make a decision as to whether to opt into the task. So in particular, like, you know, the VDEF that you're going to use, like Prio3 sum or histogram, or et cetera, is going to be part of that configuration. And the second thing, I just like taking a step back. We're not asking for an architecture change to DAP. The question here is really like, is this the scope of a protocol extension? Like, is this the sort of thing? Is this the sort of like behavior change that folks think is useful to make? Okay, that's it. Thanks.
Okay. Yeah, I think we're going to leave it there and move on to Star. Siobhan, you're up.
Yeah. Should I start? I think I can control my slides using my phone. Yeah. But hey all, Siobhan here. I'll be talking about STAR, which is distributed secret sharing for threshold aggregation reporting. Yeah, so the main idea is that we're getting K anonymity for clients, and they're reporting measurements to an untrusted server. The goals are it should be cheap, fast, simple, and obviously private. That's what we're doing over here. Just a very quick, I guess, overview, similar to what I did last time. Is the idea is that the client wants to send a telemetry value to the server, but only wants the server to see this if there are at least K other submissions of the same value by other clients. So as an example, like a JSON, you know, blob of like city, Vancouver, you can imagine the client might want to send something like this to the server. So the client generates a key by a deterministic output of like hashing its like the main measurement that it has, and then it encrypts that using the same key. So if multiple clients have the same value, same measurement, then they will get the same key. And then they all generate a secret share of that key, and they send the server the encrypted message and a secret share of the key. And on the other side, if and only if the server gets K shares, it can recover the original key, and then it can decrypt the encrypted message. This is not a new idea. This is, but we are basically using it for privacy-preserving measurement. It's also really important that there is like a proxy in between. The plan is to use OHI, but you can use your favorite network for that. You can use Tor, and there's also this idea of a randomness server. So in case the measurement has low entropy, it's in a low entropy space, then to prevent like attacks from prevent the server from brute forcing all possible measurements, you use a randomness server to get the salt, and the randomness server uses a VOPRF so that it doesn't learn the input value, but still can operate, provide the randomness. There was some feedback on the list. We've been getting a bunch, and the idea was a DOS attack using corrupt reports, where essentially the client wants to prevent recovery of a single value, like a given telemetry value. So it sends a random secret share for a given tag. So we worked on this and we addressed it using verifiable secret sharing. So we have this idea of a share commitment now that becomes a tag, and verifiable secret sharing allows checking if a particular share is valid, but like importantly, before you do recovery, so you're not wasting cycles. This adds a little bit of computation cost. It's about a big O of K in bandwidth and computation. So just moving on. But yeah, so I guess I just wanted to give a note on implementation. It's shipping in the Brave browser. The Rust implementation was the original one, and we had some WASM bindings for that. But there's also a new one that Chris Wood wrote in Go, who's also a co-author now on the draft. And I think that one's a lot more up to date with the draft. But yeah, just what's new in the newest version is that we specify the verifiable and unverifiable secret sharing. We're refactoring the document to be easier to implement. Like Chris did a bunch of work on helping us with defining the cryptographic APIs and functions. We also have defined the protocol message types for IANA, and yeah, and we also talk about garbage reports, which is this idea that the client generates a key from one message, but encrypts and sends a different message. So in this case, the recovery happens correctly, but the value will be like garbage. So there's a couple of different ways to address this. Ecker pointed out that throwing out the whole batch will, again, just cause a simple DOS, so we definitely don't want to do that. You can do like a majority vote, but like one idea that we had was you could use blind signatures instead of an OPRF. And the idea here is that you would bundle the signature that you get from the operation of a blind signature to, and then send that in your encrypted message. And then when the aggregation server recovers the message, it can also check the signature, verify it against the public key of the randomness server, and try to get that back. It's not like it's this. We haven't defined this yet in the draft, but we at least described the problem. But anyway, so I guess we're calling it Superstar now. But this idea that you can have, you can pick your secret sharing scheme of choice. You can pick your signature scheme or protocol of choice, and then they give you like more or less protection against client threats. So so I guess we're kind of recommending the third option for a lot of implementation, like the the second one, the verifiable secret sharing and the regular OPRF. You can prevent the trivial DOS attack. I think that's really important. But if you also want to prevent the bad ciphertext attack, you can also use verifiable secret sharing and blind signatures. And there's like increasing implementation complexity and cost to this. But yeah, I mean, wanted to leave some time for questions, but it seems to be pretty strong interest in STAR, and we have been addressing feedback from the working group, and it's been improving the document. So I think it makes sense to do it within the working group. Yeah, I'm happy to take questions.
Okay, Eric Scorley, you're up. I'm sorry, Martin Thompson is first. I'm reading from the bottom. Martin has first cut.
It's fine, you can talk. No hurry. Thanks for doing this. I think this sort of helps a lot. I am seriously concerned about the computation cost of recovering values once the value of K gets big. I just, you said it was okay. I think Alex and I in chat have both believed it's K squared, because each submission requires that you perform a computation across K values in order to generate the confirmation value. So every submission contains K field elements.
Mm-hmm. Right.
So that is scary. It would be interesting to see how this sort of compares to some of the alternative, like how does this compare to Poplar in terms of the computation cost involved? How does it work in practice as well? Because I think that if you're talking about a K of 100, doing 10,000 plus Ristretto computations is probably okay, but if it's 10,000, yeah, it starts looking a little scary.
Yeah, I agree. I think some more analysis on the performance aspect of it and how it compares to DApp, I think especially would be pretty interesting. Yeah.
I don't particularly care as much about the bad ciphertext thing. It seems to me like you're going to get, in the case of 100, you're going to get 100 submissions. And some of them will be good and some of them won't be. And most of them will probably be good. And if most of them aren't good, which is the sort of the point where the verifiable secret sharing breaks down anyway, you won't be able to recover them if someone wants you to get garbage anyway. So I'm not super concerned about that one. But the
Makes
verifiable secret sharing, I would love to find a more efficient version.
Thanks, Martin.
Yeah, Eric Scorla. So partly I got to say what Martin said. I think, the primary value proposition for this work ahead of Popular is performance. And so if it's not faster than Popular, then it's kind of like hard to justify. So I think we need to see some analysis of that. And I agree that the K-squared thing is pretty scary. I think maybe you meant it was O of K over the multiplied by the existing thing, which is true. Because right now you have to do O of K computations, and now you have to do O of K computations per client. So whatever. But it is O of K squared, I agree with Martin. Second, I said this in the list, there's like way too much crypto in here.
Way too much. What's
Crypto
that?
in here.
Crypto.
It needs to be cut apart into two pieces. One piece needs to go to CFRG, and one piece needs to happen here.
So, so would you say like we should block adoption until we do that?
Yeah, absolutely.
So there is a draft in CFRG right now, the Frost one, that has like that also uses and defines verifiable secret sharing. So I think if CFRG folks are interested, I think we could refactor that document and so that it can serve as a pointer to both documents.
Sure. I guess my point is if this contains stuff that like if this says GFP a lot and has scalar mult, that is way too much for this. The way this needs to work is that there needs to be a box that is called verifiable secret sharing that is sucked in and that is just consumed the same way as DAP consumes in the same way as a TLS consumes X25509, in the same way as as DAP consumes Poplar and Rio. It's and the reason for this isn't just pernickettiness about about the purity of IETF. It's about who can do the review and where it has to happen. And I skimmed the VSS thing and it's how much time does it take me to persuade myself this is correct? And the purpose of having this in CFRE is to ensure that it's correct.
Hi, Roman Genadio as AD. Splitting the document, or at least making it really clear, would only help the working group, because it's going to get to the back end of working group last call. It's going to come to PubRec for me. And the first question I'm going to have is, what's the process by which the crypto was kind of verified? Did you go to crypto panel? And now you're trying to get resources from the crypto panel. And if you had that as a work product from CFRG, it probably will go faster.
I guess my sense was that CFRG already has an adopted document that defines all of this as a sub part of that. So it seemed fine to me. Just link to it.
So now I have to read the documents and persuade myself it's exactly the same algorithms in Frost. I mean, that's considered a problem, right? I mean, if it's already there, then I guess yeah, if things already exist and you can just refactor, that's great. I'm just saying that it has to be there needs to be enough crypto in here, little enough crypto in here that we can we can just read the protocol documents and understand the protocol documents. But again, I think the threshold question really is this performance question. I think that's the thing we have to get at.
I think our sense for the performance was that it should still be pretty good. But yeah.
Yeah, I don't want to belabor the point. I haven't looked at the draft in sufficient detail, but to me, just to be in a very kind of crude metric, there's going to be a lot of things that look like kind of crypto. If it comes with a draft that says IRTF, when we go through the even kind of past me in the IETF review, it's going to be good to go. It came from CRFG. It obviously got reviewed. With us, it's going to be, if it comes from an IETF working group, oh, wow, let me try to kind of pull this apart. Oh, okay, this one's a reference, this one's not. And again, I mean, I think it will go faster.
Gotcha. Makes sense. Yeah, I'll defer to the chairs about the adoption.
Okay. Thank you, everybody, for the lively and efficient session. And I think we're all done for this edition of Privacy Preserving Measurement.
Thank you all very much.